When it comes to pesticide applications, backpack sprayers offer a convenient process, whether it's in an agribusiness or a private setting. Being able to use the same piece of equipment for a broadcast application or a pinpoint target, backpack sprayers are a popular, easy-to-use tool. And as with any application equipment, proper calibration is essential to achieving proper coverage and positive results. Without calibration, you increase the risk of over or underspraying chemical products, which could be ineffective, damaging, or even dangerous. With this simple worksheet, you will be able to see to it that your backpack sprayer is functioning as it should. These are also valuable records that can be used each season to track expenses, as well as the effectiveness of a given sprayer or application program. Because of their versatility, we're going to perform 3 different types of calibration tests in order to replicate different types of applications that can be performed with backpack sprayers. First will be a test to simulate on a row of flowers or landscape shrubs. The second will show a lawn or ground application. And lastly, a method for crop rows. The differences are primarily in the action or motion by the user. Like most calibration procedures, we'll measure a small sample during the calibration in order to determine the total output over any size area that you might be spraying. To start, let's take note of the equipment being calibrated. The first part of the worksheet gathers the basic identification information, along with the date, operator, location, and equipment being used for the calibration. Take note of the sprayer brand, the type and brand of nozzle, the tip size, swath width, and distance to target. A constant flow nozzle tip was used, so that output could only be adjusted by changes in the pump pressure. In all 3 examples, a dual compensating constant flow valve CFV regulator was used, set at 21 psi. With a CFV regulator, no matter how heavy or how light the applicator pumps the handle, output will be a steady 21 psi. Each of these 3 application methods will be calibrated using the 1/128th method. That is, measuring the time it takes to spray a particular crop or area, measuring 1/128th of an acre. The formula will then calculate how much product is sprayed on the target over the course of an entire acre. For the flower crop, calculate a length of crop row that is equivalent to 340 square feet. The length will vary depending on the distance between crop rows. Divide 340 by the distance between crop rows to calculate the distance you will cover as you spray. In this test, the distance between crop rows is 5 feet. 340 divided by 5 equals 68. Mark out the boundaries for a 68-foot test. Then measure the time it takes to uniformly spray the 340 square foot crop row. While spraying, walk at a comfortable, steady speed and maintain consistent pressure. Operate the backpack sprayer with a half tank of clean water at the desired pressure. Perform the time measurement exercise 3 times to create an average spray time for the distance. The measured times in this example were 30.25 seconds, 29.29 seconds, and 27.46 seconds. To arrive at an average time, take the total of the 3 figures, which equals 87 seconds. Then divide by 3 for a calculated average of 29 seconds to spray the measured area. Next, take that average time of 29 seconds and at the same application pressure, spray water from the nozzle into a measuring cup, ideally one marked in fluid ounces. Repeat the water collection test 3 times to arrive at an average product discharge for the 29 seconds. In this example, the 3 samples were 24, 24, and 24.5 ounces for an average of 24.2 ounces. Because the test was conducted on a 1/128th scale, this measurement automatically translates to an application rate of 24.2 gallons per acre. Perhaps you'll need to convert that application rate from gallons per acre to a coverage area of 1,000 square feet based on the product label. Take the 24.2 gallons and divide by 43.56, the number of 1,000 square foot units in an acre. This will give you an application rate of 0.56 gallons per 1,000 square feet, which when multiplied by 128 will give you a 71.7 fluid ounces per 1,000 square feet application rate. Now, let's take a look at a lawn or ground application using that same 1/128th method. As before, make sure to log all of the identification and sprayer information. Next, mark out a square plot of ground measuring 18.5 feet by 18.5 feet, which is 340 square feet. Then measure the time in seconds it takes you to uniformly spray the 340 square foot area. Remember while spraying to walk at a comfortable, steady speed and maintain consistent pressure. Operate the backpack sprayer with a half tank of water at the desired pressure. Record the time it takes to effectively cover the marked area and do this 3 times in order to calculate an average time for the coverage. In this example, the times were 42.5 seconds, 47 seconds, and 49 seconds for an average time of 46.17 seconds. Then, collect water in a measuring cup marked in fluid ounces for that same 46.17 seconds. Again, perform 3 collection samples to establish an average spray total for the measured time. Each of the 3 samples gathered in this test measured 27 ounces, making for an average collection of 27 ounces. This translates to an application rate of 27 gallons per acre, and using the worksheet calculations, 0.62 gallons for 1,000 square feet, or 79.4 fluid ounces for that 1,000 square feet. For a fruit or vegetable row crop calibration, we will use the same basic steps as in the flower or shrub test. The variation here being the action necessary to completely cover the targeted area, which will lead to different application times. Since we're still dealing with widths of 5 feet between rows, we know we'll need a test plot of 68 feet in length. To spray the test row, our 3 times were measured at 45.4 seconds, 48 seconds, and 44.6 seconds for an average trial time of 46 seconds. Remember to spray from both sides of the crop row in order to replicate complete coverage of the test area. Our 3 collected samples at 46 seconds measured at 28 ounces, 29 ounces, and 27 ounces for an average of 28 ounces or 28 gallons per acre. This gives us a 0.643 gallons per 1,000 square foot measurement, or 82.3 ounces of product sprayed in a 1,000 square foot area. As you can see, the variations in each type of application can lead to very different amounts of product being applied over each designated crop or area. This is important to remember that calibration isn't simply for the equipment itself, but for the circumstances in which the sprayer will be used. And always read the product label to understand the proper application rate for a given target. Accurately understanding the application rate for a backpack sprayer in the appropriate situation will lead to a better application with more positive results for the targeted crop or area.